Welcome to Cloud Native Live, where we will dive into code behind Cloud Native. I am Saloni Narang, and I am co-founder of QSimplify, Docker Captain, and also a CNCF ambassador. Every week, we bring a new set of presenters to showcase how to work with cloud native technologies. They build things, they break things, and they will answer your questions. Join us at every Wednesday at 11 a.m. ET. This week, we have special guests around Mackenzie and Karthik here with us to talk about streamlining Kubernetes deployments with SpinCube and selective deployments. And yes, also join us for KubeCon EU. It's around the corner in London from 1st to 4th April. See you guys over there. This is an official live stream of the CNCF and, as such, is subject to CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants and presenters. With that, I will hand over to Mackenzie and Karthik. So, why don't you take it over and introduce yourself?
Thank you, Saloni. I really appreciate that. I'm so happy to be here today. I'm Mackenzie, a product manager over at Fermion Technologies, where we're really heavily involved in the server-side WebAssembly space, and we're definitely going to get into that today. I also have with me Karthik Ganeshram, who is a software engineer also at Fermion, and also a maintainer of the Spin JavaScript SDK. If you're not familiar with Spin, that's okay. We're going to really get into it today with the presentation. And with that, actually, Saloni, do you mind if we bring up the slides so we can show what's going on with the audience?
Yes.
Fantastic. And so you might have heard that SpinCube might be discussed today. We're actually going to take a step back and start at the Spin level. So the topic today will be about Spin, which is a developer tool for writing event-driven serverless WebAssembly applications, and how you can use that along with your favorite static site generator to build static websites. So we'll learn a lot about Spin, and everything we're doing here is absolutely able to go ahead and be run on Kubernetes using SpinCube, but likely won't get to that quite today. So reframe a little bit more, thinking about static sites, and we'll go from here. As for the agenda, and if folks have any issues seeing my screen or have questions, feel free to chime in. Happy to make this really interactive. We'll be talking about Spin. So if you aren't familiar, don't worry, we have a good chunk of content prepared today to go into depth about what it is, when you'd use it, those sorts of things. And from there, we'll be talking about a component called the static file server, which is really helpful in understanding as we move to the third point on how we can combine Spin alongside our favorite static site generators. With that static file server, we're going to learn a little bit about a few interesting features of Spin and why it's really useful for composing applications. And then lastly, if we have time, we've learned about our developer tool, we've learned how to scaffold applications, combine them with technologies we love today to enhance the types of websites we're building. We might get into some day two operations and talk a little bit about how you can automate deployments with GitHub Actions, and do this all within the Spin developer tool if you would like. And with that, let's get into Spin. So at Fermion, we like to talk about WebAssembly in terms of waves of evolution. So up here, we have a 4-step diagram with the pre-cloud days where all of your application and workloads were running on hardware you're responsible for. Then came the invention of the virtual machine, and we had the ability to run a server on someone else's hardware, which was incredible. It opened up a lot of compute and the ability to build much more complex workloads. But along with that, as we're all familiar in the Kubernetes space, came a lot of questions about distributed systems and how to package and run applications. And containers really took off because they provided a mechanism to wrap up a program, its dependencies, into a single package that could be executed. They're lighter than virtual machines, but they can still be pretty big, like 2 gigabytes or larger. And so better, but not super lightweight, especially if you're handling a sort of workload or application that has to have very low latency. And that's where WebAssembly, or as the slide on the screen abbreviates WASM, you might hear us say that throughout the presentation, comes into play. It's still a pre-compiled application, but we're removing a few things. We're taking out the prepackaged file system and other lower level operating system primitives. And instead, those things are going to get attached when we need it during startup time. This makes WebAssembly applications platform neutral, really quick to spin up, and very light. So we'll be going over a few use cases and how you can get started writing WebAssembly applications today. Okay, so we have the steps in terms of evolution from local to WebAssembly, but a bit more backstory on where WebAssembly came from. It was originally invented for the browser. It's a standardized bytecode format. And designing for that actually resulted in a lot of benefits that are also applicable to the server side, which is the use case that we're going to see spin in. Primarily, it's the area that we over at Fermyon are really passionate about as well. So some of these benefits is the first and foremost is portability. You can swap out underlying node operating systems and architectures without having to rebuild or make any modifications to your application. And this is a legacy benefit of these functions originally were running in the browser, right? And so they could be running on a variety of operating systems, different types of browser. They had to work everywhere. The package sizes themselves are smaller, so we're stripping out a lot of the resources that we don't need and only attaching them when we do need them. So these applications are really lightweight, which makes them very fast to start up, as you see in that last point there. And it also helps from a platform engineering perspective in that you can host many of them on the same sized footprint because they are so small and lightweight. And lastly, they're sandboxed. So because, again, these were running in the browser, we really didn't want these applications to have access to anything that they didn't need. So there's a denied by default access model to resources on the system, and we're going to explore that in a little bit more depth today. But those benefits, again, are really nice when we're thinking about writing and working with server-side functions as well. So now that we have an understanding of some of the benefits of using WebAssembly to write and author your applications, how do we actually get our hands on this and use this in day-to-day practice? That's where Spin comes in. It's a developer tool, as I mentioned earlier, for building and running event-driven serverless WebAssembly applications. It's fully open source and now a CNCF sandbox project, which we're really excited about. And it's built on standards like the WebAssembly System Interface, or WASI is how you'd hear that abbreviation pronounced, in the WebAssembly component model. And just at a really high level, WASI allows us to basically standardize functionality that these applications are going to need now that they're operating outside of the browser. So we get portability when we think of being able to compile it down to that standardized bytecode format and run it in a bunch of different locations. But we also need some standards around, like, how do we make connect to other resources, like make outbound HTTP calls and those sorts of things, so that the application can continue to remain portable across different runtimes. So that's where WASI comes into play. Again, maybe not something you need to know if you're just getting started, but it's a helpful thing to understand, especially if portability is something that you're thinking about and evaluating when you're looking at different WebAssembly runtimes. With that, we can find us on GitHub under the Spin Framework org. And yeah, definitely come and take a look. We love to see new folks enter the community and join. And I should go into a bit more detail before the demo. What do we mean by developer tool? Because it can be kind of an umbrella term used from time to time. In this context, it's going to be three different things. We're going to get a WebAssembly runtime. We're going to get there are actually a handful of different SDKs, depending on what programming language you'd like to use. Spin has support for TypeScript, JavaScript, Python, .NET, Go, the list goes on. There's lots of different programming languages you can use. So there's an SDK for each of those. There's also a CLI. So as you see on the right-hand side of the screen, we have this triumvirate of commands. There's certainly more than this, but if you're getting started, these are the three to become familiar with. Spin new is going to help us scaffold an application. Spin build will compile it locally, and spin up is going to serve it so we can test out the functionality of this new event-driven WebAssembly application we've wrote. So with that, let's go ahead and take a quick look of these commands running in action. So I'm going to pause because we're moving a little fast here. But what we have is the spin new command in action. And what's happened is we've gotten a list of templates. And templates are basically a way for us to scaffold out the bare bones of what we need to get started writing an application, because no one wants to scaffold YAML by hand or organize all the directories. The template experience is just a really nice way to get started. You can certainly write these sorts of applications from scratch, but this is just a nice way to be set up for success at the beginning. So the format that you see used here, and it's definitely not something that's enforced 100% of the time, but you'll see that we have the trigger type, so what's going to invoke our application. Here we have quite a few options with HTTP. We also support our Redis trigger. We've also had community contributions for Kinesis trigger and a few other events, but that's what you're seeing in that left-hand side, and then the programming language that we're going to be using for the application on the right. So let's go ahead and move forward. We picked Go in this example, and we're going to be prompted for a little bit of information about that application. We're going to ask for the name and a description, and then the path. So what route is going to invoke this application? And you'll see I have 3 ellipses right here. That's a wildcard pattern. So as long as we hit the endpoint, the application is going to spin up. We could, of course, get more specific and complex with our routing if we want. But for the sake of this demo, we're just keeping it simple to start. And now we're going to move into the directory that was automatically created now that we've finished that spin new prompt. And we'll see it's generated a few files. We have our main source code, and we also have something called spin.toml, which is our application manifest. You can think of this as the one-stop shop for everything related to our spin application, where we'll be versioning and we'll be specifying which WebAssembly modules are associated with this application and their settings, what they should have access to, all of that good stuff. So we'll explore that in more depth in demos to come. But for now, you can see we're importing the SDK, and we have an event handler. And in this demo, I'm just going to go ahead and modify it to say hello to our lovely audience. And we'll exit out of this, spin build to compile it. There's a build command inside of, you can optionally include build commands inside of the application manifest. So you can get more specific with this if you have particular steps you want to include, very similar to how you might think about working with containers. And then spin up to serve it locally. So we'll check that endpoint, and we should see a hello back. All right, and just like that, that's our first spin application walking through those 3 commands of spin new, spin build, and spin up. So exploring a little bit more about what you can do with spin, we saw us write a really simple handler for accepting an HTTP event. There are other things you can certainly do with the SDK as well. You can persist data in key value stores. If you want to build a cache, you could connect to a SQLite database. We even have the ability to make inferencing requests to LLMs if you would like. And one of the cool features of Spin that we won't explore in as much detail today is that we can basically, when you install Spin, these resources are created on your behalf. So if you were writing a function that needed to make a call to a database, if in that application manifest you express that particular application needed access, Spin's actually going to spin up a SQLite database on your behalf locally, so you can practice writing to and from that. And then at deployment time, there's the ability to plug in whatever production database you might need through a different configuration file. So that level of abstraction is really nice because as a developer, you can express intent about what sort of resources your particular application needs in order to run successfully, but you don't have to get hung up in the weeds of this is the particular database that I need to connect to, right? You just are making a connection, writing a query, pulling data, and handing that off to your platform engineer to deploy and connect to the correct resources once you're ready to run in a remote
I would
location.
like to interrupt. I would like to interrupt you, Mackenzie. Sorry for that. We have one question from Hemant. So he's asking, how does SpinCube ensure isolation and cleanup of ephemeral environments? Does it integrate with Kubernetes namespaces or Azure AWS resource groups for this?
Good question. So, in case the audience isn't familiar, SpinCube is another project that allows you to take Spin applications, which is what we've been talking about at this point, and deploy them as custom resources into your Kubernetes cluster. So, there's a Spin operator that is responsible for provisioning and managing these resources, and they actually run as a pod, and it's responsible for maintaining, cleaning, and also deleting them. So I don't know if you've had anything you'd want to add to that, Karthik, but I'd say in short that the operator is primarily responsible for managing those resources. There's nothing specific to like resource groups or like cloud specific implementations in the SpinCube project itself. If there are any follow-ups on that, definitely let me know. Happy to talk to it a little bit more. So we talked a little bit about how to build a basic application that responds to an HTTP event. A common question is kind of where should we go from here? What kind of applications should we build? And the answer is there's a lot of different options for you. See anything from building simple APIs to an application that handles redirects, server-side rendering, maybe a job that just runs on a cron trigger, anything you could think of that you would tend to use a traditional serverless function. I think WebAssembly-based functions are a great option as well, and you can certainly get pretty complex with it. Today, we are going to be starting with, or really primarily focusing on static sites. That's for a few reasons. One is that when we see people enter the Spin community, tends to be one of the first places people dive in to try and learn because they run a personal blog and they want to see how it integrates. And we can learn a lot about Spin as a tool through this use case. So we'll be talking a bit about templates, plugins, the ability to reference or pull in remote components that we haven't written ourselves, and really start to get familiar with this way of composing applications. From there's a few other benefits. So we're going to have really efficient, the ability to efficiently serve static content. So we'll be talking about a component that allows us to do that, which again is a very important part of building static sites. Simplified deployments. So we're going to be able to separate out our static assets from maybe any additional functionality we add in later, but still bundle that as a single application that can be run wherever you would like to deploy it. We're going to be able to expand functionality. So Karthik and I are both going to explore this a little bit today, where we'll have our static site, but perhaps we do, we've kind of outgrown that a little bit. We want to add some new functionality in, but we don't want to migrate off of our static site. We can pull in a new functionality by adding components to our Spin application. This last benefit is more focused on the hosting side of things. So maybe not if you're running your own single personal blog, but let's say you are responsible for infrastructure that hosts many. Spin offers a really cost-effective way of running these applications. And then, as we've mentioned a few times on SpinCube, you can go ahead and actually run and host those on a Kubernetes cluster in a way where you can run many, many workloads on a relatively small number of nodes because they are idle and between requests, and they don't take up very many resources when they are active. And And lastly, the developer experience as well. So we can operate all within the Spin CLI, which makes it really smooth. We talked about some of those benefits earlier of being able to connect it up to databases. And maybe if you do need additional functionality beyond what you did just out of the box with your static site, you have a really great local developer experience that you can also take to remote environments as well. Before we're moving on, are there any questions that we want to address? I see.
Yeah, so we have another question from Sayam Pathak. Right now, it's still dependent on Kivasm, right? Is runtime class manager something that can be used already instead of Kivasm?
Good question. So I believe KWASM is the legacy project for Runtime Class Manager, which um, again, with switching context to the SpinCube project, there are a few different resources you need to be familiar with. The operator, you have a shim to go ahead and allow you to run these pods, and then Runtime Class Manager, or KWASM, which is responsible for installing and upgrading and handling shim responsibilities. And my understanding is the project is still using KWASM, but there's plans to move to Runtime Class Manager eventually. And so if you go and look at spincube.dev in the documentation, they'll walk you through the correct way of installation for now. And there is also project meetings where folks are talking about, updates to different components of the overall SpinCube project and where they're going. So that's a great place to get more update information on that.
Right. So we do have another question from Hemant. How does this tool differ from other tools like Terraform Cloud or Pulumi? Is the focus purely on ephemeral environments or does it handle long-term infrastructure too?
So I would say think of Spin more like from the developer perspective in terms of we need to it's the tool you use to encompass and package your application, whereas Terraform Cloud or Pulumi is about infrastructure. So um, Spin is going to allow you to write an application that might have intent to connect to external, or that likely would have intent to connect to external resources like databases, key value stores, et cetera, but it's not going to provision them for you on your behalf. So using something like Terraform to set up those resources that will later be connected to from your Spin application, like they kind of go hand in hand. You would use both in that scenario. So Spin does not handle long-term infrastructure, that sort of thing. If you're using SpinCube, again, to deploy that Spin application to a Kubernetes cluster, you're going to, that project is responsible for maintaining the Spin applications themselves, but nothing outside of that. So you would continue to use your other tools in that context to set up those other resources.
Yeah. Thanks for answering.
Yeah, of course. These are really good questions. Okay, so we talked a little bit about why we're focusing on static sites today, and how they tend to be a useful entry point to the Spin project, albeit you can come at it from a lot of different other workload scenarios as well. So in order to get eventually to our static site generators, it's important to understand a little bit about the Spin static file server. So if you're looking for a mechanism to quickly and efficiently serve up static files, this is a great template to go ahead and get started with. I really like this example because what we have is a common pain point, right? A lot of people need to serve up static files, right? And it's the same logic you're writing over and over, maybe in multiple different applications across different teams. And you could really just solve for it once. And that's what we've done with the static file server. It's a simple REST application that's going to read files from the file system and serve them over HTTP. There's a little logic in there, adding compression and caching headers to make it slightly more efficient. And yeah, that's its one purpose. It does its job and it does it well. And you can now take this WebAssembly module and pull it into whatever application you're writing. So any use case where you need to deliver images, style sheets, other static assets, this is going to be a good good component to add to your application to do that job for you. This is getting a little bit into the weeds. We'll explore this a bit more when we actually go to the live demo. But in case you're curious about how this is working behind the scenes, this is an X-ray view of how the file server is going to work. So typically, we're only going to be interacting with what's in this box here of the Spin application and the file server and the file system. But let's dig in a little bit to understand exactly how it works. So imagine we've taken that lovely file server and we've pulled it down. You can install templates over the Spin CLI, which is what we're going to see done live today, and have it running locally. And you send a request. What's actually happening behind the scenes? So the request is going to be sent to your Spin application, and the operating system will forward that request to the Spin process, which is going to evaluate it on the route we've passed in. So you'll see this in practice, and we did this a little bit earlier, but we pass in the path right whenever we're creating that Spin application, and that's what's going to be evaluated. And if the request was correctly formed, then it's going to get routed to the file server component. And the way in the application manifest, we're going to specifically give that file server permission to read files from the disk. And this is done through WASI, the WebAssembly System Interface we talked about earlier, that is granting capabilities to specific components. So because we've said, hey, this is an okay directory for you to go ahead and read from, it will have the ability to go ahead and check for those files and then return them back to be served to whatever client has sent their request originally. So it's a good example, and it'll probably make a little bit more sense when we're actually looking at the application manifest itself, but how we have to specifically add in capabilities to this sandboxed model in this application. So a little bit of a deep dive to give us a bit of appreciation for what we're going to do here. And with that, I'm going to switch my screens and bring up Terminal instead. If you're curious about following along at home, you can go ahead and scan that QR code, and it's going to take you to the static file server. I recommend having Spin. You'll need Spin installed first, but you can definitely follow along if you're interested. So bear with me because we're going to switch screens here for a second. I'm going to pull up. There we go. Can folks see my terminal? And I probably need to bump the font size quite a bit, huh? Is that okay?
Looks good. Yep.
Great. So what we're going to do is create a Spin application using just the file server to start with, and then we'll get a little bit more complex as time goes and add in our static site generators. But let's first learn a little bit about how we can serve files. So I've already gone ahead and installed this template ahead of time. Karthik will walk through what the flow looks like for installing templates over the Spin CLI. Essentially, you're just referencing a Git repo that's going to go ahead and have this already published. But for now, I've done this ahead of time, so it's already included in the list of templates that I have available to me today. So we'll select this. This is just a simple demo, so we'll call it my pictures, because we're going to write just a simple app that's going to serve up photos. Example of Spin's static file server. Here's our path. So this means anything under static wildcard pattern will match. So let's do that. For now, we're happy to go with the defaults. We could always get more complex with the routing if we wanted to. And then this is the directory that we're going to give the static file server permission to access and pull content from. The default term they have in here is assets. You can use whatever you want. Again, let's just stick with defaults to make it easy today. And let's check out what was created. So we have our assets directory, and then we have our application manifest, and nothing's in there quite yet. So let's go ahead and add some content to serve up. And I couldn't turn down the opportunity to, actually, here we go. We need to move in the right folder. Showcase a picture of my cat. Her name's Holly, so she's going to help us out with the demo today. And now that we've added content to our assets folder, before we actually run this application, let's take a little bit of a look at what our application manifest looks like. So that's our spin.toml file again. We have the name of the application, other metadata. It's an HTTP trigger, and it's going to match this route with this particular component. And so a component is a WebAssembly module along with any sort of configuration that needs to go alongside with it. And the spin application is composed of one or more components. So here we have, just to keep things easy for demo's sake, a single component spin application. The source of the WebAssembly module is remote because I personally have not written this static file server. I'm pulling it in, and we're double checking the SHA just to make sure it's the correct. We know what we're pulling into our application, and then this line is important because it is what's granting our application access to the file system. So this is what's using WASI behind the scenes to say, okay, this particular component should have access to the assets directory, and it can pull and serve content from there. So we'll pop back out, and then we will run our application. And I'm going to have to switch screens one more time because terminal's not going to do the static content justice here. Can folks see Google? Great. So we'll go on under
Yes.
localhost, the static path, and then the image we added. And there's my cat. She tends to sit there and watch me work, so that feels appropriate. And that's how static file server works in practice. Now we can get a little bit more complex with it. I'm going to pull the slides back up. In the meantime, any questions so far from folks? Did I see anything new?
No, nothing new right now.
Right.
But I do have one
Yeah.
question. So, how does Spin static file server simplify the deployment of static sites? What are the advantages of this approach offer?
Yeah, it's a great question. If we could bring the slides back up, it's actually, you timed that beautifully because now we're going to talk about why we would use the static file server with our static site generator.
Yes.
That's great. So a few reasons. One is if you want the ability to have like full control over where you run this application, packaging it in a spin application is going to immediately make it portable, right? Now we're serving the static content and we can run this anywhere that we would like to run basically a spin app without having to worry about the architecture of the underlying host. It makes integrating with CI/CD pipelines so much easier because you can just continue to run that as is without having to worry about making any modifications to your runners. And we'll talk a little bit about how you can actually set up GitHub Actions with the Spin CLI as well. It's great for performance. So you get that sub-millisecond startup time with your application. So you're going to be able to serve content in a really performant way. And then if you ever grow beyond just wanting to serve static content and add some dynamic functionality to your application, you are able to go ahead and add in new components. We'll explain how to add in functionality from an API and continue to be able to wrap this all in a single spin app that you deploy and manage, which is neat. One question might come up is like, what static site generators could I use with Spin? And the answer is all of them. Like, as far as I know, I can't think of one that wouldn't work because you're simply just serving up static assets. So The examples that I have up here are ones we already have templates for, so you don't have to worry about trying to integrate your directory structure of your static site along with Spin. This is already done for you. If you don't see your favorite static site generator on here, we love to get more examples and templates, so I definitely encourage checking out Spin Hub, which is a resource associated with the Spin project, where you can find community-driven samples, and really runs like a large variety of anything from like plugins to, again, templates. So when we were using that static file server, that was a template that we can install and run. Libraries, we have simple samples that will show you how to use perhaps a particular aspect of an SDK, or we have all the way examples running all the way up through like architectures and more complex patterns. So that's my short plug for checking this out and seeing examples. And everything that we're showing today, again, came from the Spin Hub. So you can definitely check it out on your own time and see what's out there and see if what you're building is there, and if not, maybe contribute a new sample or two. Okay, now to the roundup. We're not going to go through all of these today. I don't think there'll be enough time, but we are going to explore one or two and look at how we can take that static file server and use it to serve the assets from our favorite static site generator, and maybe add in a little bit of new functionality as well. So with that, I'm going to go ahead and share VS Code instead of slides. Make sure we'll pull up the right one. And we're back, and that's going to be a little bit small, huh? Okay, so I've skipped a few steps here, and we've gone ahead and installed, cloned a repo. This is the example put together using Hugo, which is written in Go. That's pretty popular static site generator along with Spin. Torsten actually put this together. He's a developer advocate over at Fermion. So if you're writing a Hugo site, this might be an interesting place to go ahead and start. You can see here we have everything we'd expect from our static site already running. And what we've done is actually just added our Spin application to the project, which is a little bit unique. You tend to see Spin at the root directory, but we're doing things a little bit different. I wouldn't say it's wrong, but just calling it out is that might be a little bit, if as you go to other examples, you might see a slightly different directory structure. So looking back at some of the concepts we covered today, we have our metadata, we have our trigger. So we just have the basic HTTP event that's going to go ahead and map the wildcard route with our component called app, which again is the same file server we used to serve up the cat photo earlier. We've gone ahead and given it permission to access everything in the public directory and serve that with a fallback path if something were to go wrong with index.html. So far, when we've been building and running applications locally, we've been using the Spin command, but Torsten's actually gone ahead and created, excuse me, a makefile because we wanted to add in a little bit more functionality from Hugo specifically, where we can serve up drafts if we would like. So we're going to use that, but you could certainly modify your build command in the app manifest if you wanted to do that as well. So we're going to go ahead and hit make start. And we have something going on, which is interesting. Let's go ahead and take a look as to what the issue is. Oh, already in use. So that's a good point. I didn't stop the static file server example we had going. So it's going to say, hey, what you're asking me to run is actually already occupied. So now we have our static site up and running and served on that port right there. And to make things a little bit more interesting, let's go ahead and add a blog and just see how we can continue to use Hugo functionality if we would like here. So we're going to kill the process, and what we're going to do is go ahead and add a new blog using the Hugo CLI. So what we're going to do is say Hugo new, and then I believe it's the directory here is called posts, and then we'll say hello CNCF, and you should be able to see here we have a new post available, and if we hit make start, we'll go ahead and actually check that out in action. Let's see. Let's switch over to browser and just see what that looks like. And I see a question of what tools are available for debugging spin applications. So we actually have a plugin called OTel, which is the acronym for Open Telemetry, that's going to go ahead and take your spin application, plug in a set of environment variables that's going to give you access to Jaeger for traces. I believe there's a Prometheus instance that you can go ahead and look at metrics, and you can also take a look at logs as well. So there's a whole stack that's already available by simply using the Spin OTel plugin. So those are all available for observing your application. We don't have breakpoint debugging ready quite yet for WebAssembly applications, so that is one thing that isn't quite available, but there are a lot of resources you can have to go ahead and actually take a look at what's running inside of your application there. And just to get to the other side of the demo, we have it's small, but now we have our Hugo site that's currently being served by our Spin static file server. And yep, we're able to have our new post, and it's available right there. Great. All right. And then we'll go ahead and modify one thing going back to VS Code. Okay, so we saw in that example how we were able to go ahead and use static file server to run our Hugo site. And what would be nice is, let's say we've kind of gone beyond just serving up static content, and we're looking to find ways to increase engagement on our blog. And we're not quite sure. We could write more content, but we want to maybe add some dynamic functionality to that app to see if we can get the audience engaged a little bit more. This is a silly example, but what we're going to do is add a component here that I've written that is going to give us trivia facts. So on our website, we're going to add a little widget to the bottom of all of our posts that's going to ask the viewer, hey, here's this one little bit of trivia. Again, just to show how we can add dynamic content to our app, to that same application really easily. And again, this is written, so it's already been pre-written and released on a remote GitHub repo. So we're pulling it in. I'm pasting it manually. You could certainly publish this as a template, so we could go ahead and use that nice spin add functionality and have everything scaffolded for you. That would probably be preferable. But for now, just really quickly, I'm going to be adding this in. You see here that it does not have access to the file system. So our API doesn't need to have access to all of those assets. So we're not going to include it. It won't. That is an important point, is that the capabilities are granular at a component level. But what we do have is the ability to make outbound HTTP calls to this endpoint, which is going to be serving up the trivia facts. So without that, this wouldn't be able to function. So you can see examples of two components that have unique capabilities based on the tasks that we're asking them to do. And I also have to go ahead and add a trigger. So this is going to correspond to our API component. And let's give it a more specific route here. There we go. And this is going to be a little bit of the cake has been baked ahead of time, where I've gone and written this partial already to add the trivia functionality to our website. And I'm just going to simply now have it render just for the sake of time with this demo. And with that, if I successfully manually plugged everything into my app manifest, I should be able to say make start again. And we should be able to see our new trivia widget. So we'll pull up Chrome one more time.
So we do have two questions,
Yeah.
Mackenzie. So Kaushila is asking, spin cube is a demon.
Um, so spin cube is a combination of a few things. It is a operator that's been written, so spin operator that's going to go ahead and be responsible. Here, we can actually move over for a second. It's a combination of a few things. We're going to do a little. It's a operator that's responsible for the workload management of your spin apps that are running as custom resources. It is there's runtime class manager or KWASM that's going to go ahead and install a shim, which is required in order to run those custom resources on the same nodes as you might be running traditional containerized workloads. And then there's also optionally a plugin, which allows you to take that spin application like the static site we've been running today and transform it into the CRD that you would feed into the spin operator, which is just a nice to have tool. So no, it's not quite a daemon. The run class manager is responsible for applying the shim and the rules to the node so that the spin app knows where it can be run and deployed, but it's not a daemon set.
So we have another question as well. So how does spin WASM-based approach benefit static site generation compared to traditional SSGs? Are there examples of hybrid static dynamic sites?
Yeah, so it definitely gives us the ability, again, it gives us portability, it gives us the ability, like once you've wrapped it in a spin application, you can serve that website wherever you can run the spin runtime, which is anywhere you can install on a node. It makes, running through CI/CD easier because you have all of your assets separated out from any other additional logic, so you can have more controlled rollouts. And then an example of a hybrid application is kind of what we've built right here, right? We have our Hugo static site that's rendering our posts and all of that good stuff. And now we've added a component that adds some dynamic functionality. Again, it's just kind of a trivial example, but of having trivia questions being added to your site. So now we have some dynamic content that's interacting with the user, all from our original static site generator, combining those two things together. And with that, I think that covers everything I had for the Hugo example. I think Karthik's going to go ahead and show us a different static site generator and also explore a little bit. I've been talking a lot about the application manifest and the Spin CLI, but we haven't really dove into the SDK side of things. So he might take us on a little bit of a journey with the Spin JavaScript SDK as well. Karthik, do you want to take it from here?
Can I share my screen? So let's start with just as Kenzie had mentioned earlier, like Spin has the notion of templates, which gives you like a starter from where you can start building out your applications. Just this afternoon, I created a template for 11T, which is a JavaScript-based static site generator. So, and that I have it on a repo. And so to install it, all you would have to do is run spin templates install and then point at the Git repo, which is which is the command I have here. And we can go ahead and run it. We will see that it has installed a template called 11T spin. And we can go ahead and start using it with spin new. And create a new application. It has a description, and I'm choosing just to use this as the default path. So if you go into hello 11T, and we can see it has scaffolded an entire project for us. And like if you look at the spin.toml, it's going to look very similar to the other static site generator, where you have your static site generator, and then you have where the files that it has to serve from. And like you can also interestingly see there's a build command called npx11t, which is the command that you would use to build your blog. Since 11t is a JavaScript based static site generator, let's go ahead and install the dependencies for it first, which you can do using npm install. And I will move this up. And once that is done, we can run spin build. Spin build is a command that allows us to build our spin application. So if I do spin build, you will see that it internally calls the 11t command. And now we have the site folder, so which has built our application. And then you can just do spin up, and you can it says it's serving the application. And if I go here and refresh, you can see the 11t blog. It's as simple as that. Like it's very similar to how Hugo works. The more interesting part of where Spin provides advantages of using static site generators instead of the traditional servers that you can use for static site generation, similar to what the last question asked, is like if you want to add some dynamic content, like you want to have a like button counter, like to see how many people have viewed a post, like how many people have liked a post. You can do those kind of things. And also the other thing you can do interestingly is you can write a component in your Spin app that proxies the static site generator, but you can customize the response of the static site generator based on some user parameters. Like let's say there are cookies, so you can use those cookies to come up with custom content or whatever it is on top of the static site generator. The other advantage of using Spin here would be that it kind of covers all of the pieces together as a single application, instead of normally where you would write your static site generator and it being served somewhere, and then you would write your dynamic functionality elsewhere, and then you have to reach out and do things. This makes like the local testing part quite reproducible to how it will work when you deploy the app to your deployment environment, wherever that is. That's one of the biggest advantages, is the local developer experience and the reproducibility of how it would work in prod. Since you can to add a JavaScript component, all you would do is, let me clear. You would do a spin add, and I like TypeScript usually to prototype things. So let's say API, I add a component, and then I want it to be serving at .api, all the routes subcarded by API. And so that if I go back into Hello 11t, we can see an API component which has a TypeScript application bootstrap for us, which is just using ET router, which is a minimal JavaScript router that is common and used quite often. So this is the base application, but again, as Kenji used the phrase, bake the cake already. I already have a demo application where I did pre-populate the API with content in there. So we can quickly look at the code there. What we are doing is we create a router with two endpoints where we do an get and post. The goal of this dynamic function is to basically keep a track of how many likes each post has received, so that like when someone else opens the blog, you can show a like counter at the bottom and be like, 4 people have liked the blog, 5 people have liked the blog. So when we get a get request for a particular path, we create a key, and like Spin has a key value store where you can store your values so that they are persisted across functions. Like Spin by default is the HTTP trigger is usually used in like serverless environment, so there is no data persisted from one call to the other. Key value store is how you persist data across requests in cases like this. So all we do is we get a request, and then we store the value. And for the post request is how we increment it. Basically, if there's someone sends a post request for a URL, we are like, oh, okay, let me increment the count by 1 and store it back into the key value store. The interesting thing to look here in the spin.toml, if we look at the API component, is we have to specifically allow it the ability to access a key value store. Without this ability, the spin app or the wasm component will not be able to access the key value store. So it's like by looking at the manifest, you're able to pretty much assume what capabilities a component has, like the privacy. Like for example, the component by default cannot do any outbound request to URL, so you can be safe your data is not leaving the component. So that's the capability-oriented model of spin, where you have to explicitly allow it. And to now run it, let me just go into the other directory. And if I run a spin build here, we see that it builds two components. Like it's now building the JavaScript. Like you can see, it's building a second component using npm run build for the API component, and then it has built both. And then you can run a spin up. You can see that there are two routes being served here, one being the API and the other being the 11t demo, which is the static site. And if we go back to the browser, let's refresh and let's go into a post. If you scroll all the way to the bottom, now we see a like button. And if I click it, you get a 1, and I can refresh the page multiple times. And it's basically just getting the data back from the server and showing the value there. This example was originally written by a colleague of mine, and he had written a HTML script which stores it in local storage so that you're not allowed to click on a like button more than once. It's a naive way of doing it, but if you would need authentication if you want not to allow one person to like a post more than once. But we can quickly check if that works by, let me go back, look. Since in incognito mode, you do not have any of the local storage buttons. Like if I go here and I can click it too. So that's how it works, because there is no local storage in incognito. And that's why it let me like the second time. That's the JavaScript example I had built for the static site generator.
Awesome. Thanks for giving another use case on how we can, again, augment static site generators with new functionality and add some dynamic behavior using Spin. We might have enough time to quickly go over a CI/CD example in the last few minutes. Anything else you want to add to that one, Karthik, before we switch over?
No, that's about it.
All right. Thank you. We're gonna go back to 11t really quick. I'll pull up my command prompt. So we gave a few examples on how we can use different static site generators, explored that. And now we're going to go into a day 2 operation where we've run our site, we've tested it locally, and now we really want to be able to quickly make changes, deploy to our GitHub repo, and then have that go and run somewhere in whatever our production environment is going to be. We're going to do this all within the Spin command line. In order to do this, we're going to use a plugin. It's called the Spin GitHub plugin, or Spin GH for short. Thorsten has written this, and you can find it. I'll link a QR code right after this that is basically going to go ahead and kind of solves the pain point of I really don't want to have to break out of my developer flow and go ahead and like work with GitHub Actions, either writing the YAML manually, or maybe you go to the user interface and you have to do write a bunch of add additional configuration in order to get that runner up and going. So what we're going to do instead is going to use the Spin GitHub plugin. So what we're going to do is run within the directory. It's important we have to be inside of our Spin application directory, and we're going to run Spin GitHub create action, and we're going to pass in the CI flag for continuous integration. This is a pretty simple example. You can definitely get a lot more complex. There are a bunch of different flags that would allow you to, let's say, pin a specific version of Spin, maybe install other plugins. So again, an example would be, just say the Kinesis plugin, and we want to have that used to trigger our application. We might include install instructions there. Maybe you need to install language-specific tooling. All of this you can actually get really fancy with within this command. We're just going to keep it simple today. And it should by default typically accept main for continue for CI, but let's pass it in manually. And what you'll see here is now we have our workflow and our CI YAML created for us, where we go ahead and install Spin, language-specific dependencies, all of that good stuff. And what we're also going to do at the very end of this is I'm going to add on a step to deploy to Fermi on Cloud, which is a managed environment for deploying and running Spin applications. I have everything set up ahead of time. Let's get the indentation right there. So I've passed in a personal access token that's going to allow us to deploy. You could just as well, we've had a lot of great questions about SpinCube today. Have this packaged into an OCI artifact and have that pushed somewhere that perhaps your platform engineer would then pull down and run with SpinCube. So there's definitely ways you could take this and apply this to connect to perhaps a Kubernetes-based environment. So we'll go ahead and added GitHub action and push that. And if we take a look at my registry, we should go ahead and be able to see everything, a runner being triggered there. So let's take a look. Going to switch contexts really quick. Okay, can folks see Spin 11T? And we should have just seen that push. And then if we look at actions, looks like we might have had, we have a syntax error on this one that we can fix really quickly on line 30. But essentially there we have our action up and running and actually able to go ahead and deploy on our behalf. I'm going to make this change without having to switch screens on everyone. Updated syntax error. And with that, we should see a different action being triggered here really quickly. Okay, we're still fighting the syntax error, but you can see here through previous workflows that we went ahead and built successfully, and we actually do have this running over on Fermion Cloud. If we go and take a look, we can see our 11T website up and running, and the last successful deploy was a little bit ago when we didn't have the syntax error, but now our website's up and accessible and running, available at this endpoint. So just a way to connect your local development flow up into your production environment. All right. And with that, we'll get to the very final slide of today's presentation with a few call to actions. So thank you so much for joining and learning a little bit about Spin and how it interacts with static site generators and sprinkling in a little SpinCube as well. Here are a bunch of different places you can get involved. We have our Spin channel and the CNCF Slack. We have project meetings, so this will take you to the Google Doc meeting notes if you're curious about what we talk about or want to learn more. It's a great place. We meet every Monday, so I would love to see folks there. And then the Spin Framework GitHub organization as well. These are all good places to check out if you enjoyed learning about Spin and you'd love to get a little bit more involved. And that's all we have for today.
Yeah, thank you so much. So we are running out of time. If you have further questions, reach out to them, join Slack channel. And thanks everyone for joining this episode. It was great to have you, Mackenzie and Karthik today. We enjoyed a lot. And we also love the interaction and questions from the audience. Thanks again for joining us today. See you. Bye bye.